Illustrative Math, Algebra 2, Unit 4, Lesson 16 is called Using Graphs and Logarithms to Solve Problems, Part 2. All right, so a quick little review here. If I have two functions, and let's say, so this is my first function, f of x, my second function, g of x. Obviously, f is the red, g is the green. The two functions intersect at a y value of 40, okay, because if I drew a line right here through 40 right there, or if I drew the line y equals 40, you see that these lines intersect right there. What's the x value? Well, you would have to draw a line right down here to see where it intersects. And that looks like it's about, let's see, these go by 2, so 12, 14, 16, 18, 20. So 14 would be my answer. Okay. So what that means is if I plug 14 into these functions, I'm going to get the same value, which would be 40. So in other words, you could say f of x is equal to g of x when x equals 14. So really, I'd say f of, let's write it like this, f of 14 equals g of 14. Okay. So if I plug those in, I should get 40 equals 40 is really what's going to happen. Okay. Just a little review. All right. So our goal today. I can calculate where two exponential graphs meet using logarithms. I can interpret the intersection of the graphs of two exponential functions in context. All right, so here's our warm-up. A business owner opened two different types of investment accounts at the start of the year. Functions f and g represent the values of the two accounts as a function of the number of months after the accounts were opened. So it's really, think of it like f of m. So months go on the inside. Here are some true statements about the investment accounts. What does each statement mean? Okay, so f of 3 is greater than g of 3. So what does that mean? Well, that means that, hang on a second, let me change this color here. All right, so means at 3 months, investment account F has more money in it than investment account G. Okay, because F at 3 is greater, okay? F of 6 is less than G of 6. So at 6 months, investment account F has less money in it than investment account G. And f of m equals g of m. So that means at m months, investment account F and investment account G have the same amount of money in them. Okay. If the two functions were graphed on the same coordinate plane, what might it look like? Okay, so let's see if I can draw a rough. Oops, I need to go this way. So these are my axes here. So they're both exponential growth, I think they said. I guess it doesn't say that they're exponential. I would assume it's exponential because it's an investment. So F starts out greater, and then all of a sudden G becomes greater. So they're going to have to cross at some point. So if F is my blue graph, here's F, okay, G is going to have to be, let's do it in green. G is going to have to start out less, and then at some point it's going to have to pass it up, okay? So here's M right here. That's where they're equal. Maybe 6 is over here, and then 3 would be maybe like here somewhere. I don't know. So at 3, F is above G. At 6, G is above F, and then at M, they're equal. Okay, so it looks something like that. All right. To study the growth of bacteria in different conditions, a scientist measures the area in square millimeters occupied by two populations. The growth in population A in square millimeters can be modeled by this function f of h, where h is the number of hours since the experiment began. The growth of B can be modeled by this function g of h, and here are the graphs. Okay, so in this situation, what does the point of intersection tell us? So it tells us when the populations are equal. Okay, so right there where they intersect, that's where the populations are equal. Okay, so the number of hours and the population where the two functions have the same amount of bacteria. So if I were to kind of take a look at that, it looks like it's roughly about 5 hours, and they're going to be about like 170. Okay, so I would maybe say, at 5 hours, both populations will have 170 I think it's millimeters squared. So that's your area. All right, suppose the population coordinate of the point of intersection is 171. Okay, so I was a little off, 171. Explain why we can find the corresponding time coordinate by solving f of h equals 171 or g of h equals 171. Okay, well, both functions, I would just say both functions, go through the same point, so we could set either one equal to 171. Okay. All right. We could also solve the equation where they're equal, and I would say yes, they both equal 171. Say, so yeah, we could set them equal. All right. So solve either f of h equals 171 or g of h equals 171. Show your reasoning. Okay, so I'm going to come over here. All right, so let's see here. F of h is 24 times e to the 0.4 h equals 171. Okay, so in order to solve this, we got to first divide by 24, because that will get rid of the multiplication. So my next line here, 171 divided by 24, gives me 7.125 equals e to the 0.4h. So now I'm going to write it in logarithm form. So it's log base e. So we know a natural logarithm is basically log base e is the same as saying natural log. Natural log has a base of e. We just don't write it. So natural log, so base e of 7.125 equals 0.4 to the h. Okay, divide by 0.4 because we want to get h all by itself. So there's your answer, h equals. Now this is exact. If I want to do it in decimal form, I just type in natural log of 7.125 divide by 0.04, and sure enough, I get 49. Why is it 49? Why did I not get 5? It should be 5 hours. Okay, I looked at my math and I typed it in wrong in my calculator. I did get 5. Natural log of 7.125 divided by 0.4. I think I typed in 0.04. That's why I was getting the wrong number. It's 4.9 hours, which is pretty much what it looks like on the graph. Now I said 5, but 4.9. Okay. So there you go. Now I could do the same thing if I took the other graph or the other function. I said 171 equals, what was that here? 9 times e to the 0.6 right there. Okay, so I'd get the same answer. Okay. Solve f of h equals g of h. Show your reasoning. Okay. So f of h was 24 e to the 0.4 h. This is 9 times e to the 0.6 h. So show your reasoning here. So what I'm going to have to do here is I'm going to have to divide each side by 9 or divide each side by 24. Or I guess, you know what? Instead of using algebra here, we've kind of already found the answer here because we know that all three of them are equal. F of h equals 171, g of h equals 171. So basically, we already found the answer. So I guess rather than doing the algebra here, I'm just going to say h equals 4.9 hours because I already solved one of them and we already said that they're equal because they intersect there. Okay. All right. Population in millions of country C is given by this function f of t. Population of country D is given by this function, function g. In both equations, I think that's supposed to say t is the number of years since 1980. Will there be a time when the two populations are equal? Explain or show your reasoning. So I guess what you got to look at is you got to look at the initial value and the growth rate. So like let's look at C, country C, which is this function. So 16 is my initial value. Okay, that's the number in the front, and then this number there is your growth rate. So it's 2% growth. If I look at D starts at 17.5. So it starts out at more, and then the growth is 2.5. So it grows faster. So I don't think they'll ever equal because if you look at the two of them, C starts out less. The only way C would catch up to D would be as if it's growing faster. So what I would say here is something along the lines of, I would say, oops. I would say no country C starts at less than country D, and its growth rate is also less than country D, so it will never catch up. Okay. At some point in time, the population in country C reached 30 million. When does this happen? Explain or show your reasoning. So country C, I'm going to set it equal to 30 because I think it's in millions. Yeah, population millions. So I'm going to set it equal to 30. 30 equals 16 times e to the 0.02t. So let's divide each side by 16. And let's see what that gives me. 1.875 equals e to the 0.02t. Let's write it in log form. So log base e is natural log of 1.875 equals 0.02t. So then I divide by 0.02. And that'll give me my time. So type it into your calculator now. Natural log of 1.875 divided by 0.02. I get 31.4. Now what is t? T is the number of years. So when does it happen? So it's years since 1980. So it's 1980 plus 31.4 years. So I would say that happens in 2011. So 1980 plus 31.4. So 2011. Okay. So let's also take a look at these graphs here. So here's where you can see, here's my y equals 30 is the black line. So population D is the purple one. C is the green one. So here's where I set population C equal to 30. Okay, so this is y equals 30. And then this is that function here, 16 times e to the 0.02t. So I did it with algebra. And then when I look here on the graph, the x coordinate's the same number, 31.4. And then kind of like I explained in part one, you see here D starts out above and it grows at a higher rate. Notice the curve is more bent. And then you look here at the green one, country C. This one is starting less and it's less bent, so it's not going to catch. They're gonna continue to get farther apart as the time goes on. Okay, so that's kind of how that works. All right, so suppose we have two functions modeling the growth of two types of cells as a function of time and days. Function modeling the number of type A cells is defined by A of D, and the function modeling the number of type B cells is B of D. How can we tell which is growing faster? So we're going to need to look at the growth rate. So to answer this question, we're going to look at this value up there in the power with E. So I would say type B is growing faster. Because the growth rate is 4.5%. Okay, 0.045 means 4.5%. You got to move it 2 to the right. Versus type A growing at 3%. All right, if we graph two functions, they intersect. What do the coordinates of the intersection point tell us? Well, that tells us the number of days. I think it's D for days, number of days. Number of days when the two functions will have the same, or the two functions will have the same number of cells. Okay, so the days would be the x coordinate or the horizontal coordinate, and the number of cells would be the vertical coordinate. Okay. How might we find out which day there will be the same number of cells of each type? So we could obviously graph them, find the intersection point, or we could set them equal. The problem is the algebra will get a little bit messy there if I set them equal. So I would say, whoops, I spelled the coordinate wrong. I would say we could graph them, find the intersection point. Okay. And the x coordinate, the horizontal coordinate, would give me the number of days. Okay. All right. So our goal, I can calculate where two exponential graphs meet using logarithms. I can interpret the intersection of the graphs of two exponential functions in context. Okay, I'm going to actually go back. I was looking at something here, and I apologize. I'm going to go back and I'm going to do this here with algebra instead of just looking at the graph. So if I set these equal, it'd be 400 times e to the 0.03d equals 300 times e to the 0.045d. So to do algebra here, let's divide each side by 300. Whoops, not 3,000, 300. So I'm going to get 4/3 e to the 0.03d equals e to the 0.045d. Here's where it might get a little tricky. You're going to have to, since this is still times, if I divide each side by e to the 0.03d, okay, that gets rid of that. And what that does is it takes me to 4/3 equals e. Now remember, if you divide with the same base, you subtract the power. So I'm going to do 0.045d minus 0.03d. So that gives me e to the 0.015. So now I can put in log form. So I say ln, so log base e of 4/3 equals 0.015d. Now I can divide by 0.015. That'll get me here. ln of 4/3 divided by 0.015. And now I can actually get the number here. It's 19.2 days. Okay. I'm going to also go back to that one slide where I didn't do it algebraically, because that is a goal of ours here. So I think it was this one here. When I just kind of looked at the graph, I'm going to do it the same way that I just did. So divide by 9. So 24 over 9, I think that reduces, be 8 over 3, I think. Yeah. So let's change that. 8/3 e to the 0.4h equals e to the 0.6h. So then if I divide by e to the 0.4h, I get 8/3 equals e to the, subtract your powers, e to the 0.2h. Now I can write it in log form. So log base e is natural log of 8/3 equals 0.2h. And then I can divide by 0.2. So I type in my calculator, natural log of 8/3 divided by 0.2 gives me 4.9 hours, which is what I had over here anyways. All right. So sorry about that. I should have done that earlier. So last thing, cool down. So here's my function P of n. Initial value is 18, growing at 3.5%. This represents the population of a town in thousands, n years after 2000. Describe at least 2 ways to find or estimate the year when the population of the town will be 40,000. So 2 ways. One way would be graph y equals 40,000. Whoops. Or really y equals 40 because it's in thousands. And find the horizontal coordinate of the intersection. So if I graph that, it looks like right here, looks like they're going to intersect right there. It looks like probably about 23 years since 2000. So 2023 would probably be about when it is. So the other way is set P of n equal to 40 and use algebra. So let's do it. So 40 equals 18 times e to the 0.035 n. Divide by 18. So I get 20/9 equals e to the 0.035 n. So let's write this in log form. So log base e is natural log of 20/9 equals 0.035 n. So then we got to divide. So I get n equals, let's see if it's close to 23. Natural log of 20 divided by 9. And then I close on my parentheses, divide by 0.035. And sure, yeah, pretty close, 22.8. So pretty close to what I had said, 23. So approximately 2023. All right, thanks for watching. Hope you enjoyed this video, and we'll see you next time.